Module 5, problem number 6. Assume that the differences are normally distributed. Complete parts A through D below. So we have a data set here with our 1 through 8 observations. The first row is X. The second row is Y. Part A, determine DI with equal to XI minus YI. So basically we're looking for the difference between our X variable and then our Y variable. And it says for each pair of data. That's our hint that this is matched pairs data. So in this one, we have our observations 1 through 8 and then the differences. So let's go ahead and do that in StatCrunch so we don't have to manually calculate each difference. So once we open the data set in StatCrunch, we have our 8 observations, our X column, and our Y column. To create a new column with our differences, we're going to go to Data, Compute, Expression. We're going to build it. So we're going to click on XI, Add Column, Subtract, YI, Add Column, and then I'll show you, click OK, and Compute, and it creates that new column. You can either leave it as that, or I'm just going to call it DI just for, it's not completely important, but let's go ahead and make this screen a little smaller just so we can see them at the same time. So let's go in order. We have negative 4.6, 0.1, negative 4.1, negative 3.8, negative 2.1, negative 1.9, negative 2.1, and negative 2.1. Let me just double check. Make sure we got, okay, check answer. There we go. That was pretty easy. Now, one of the reasons also it's nice to do this in StatCrunch versus doing it in like just manually is now you have that column. So for part B, it says compute D bar and SD bar. So basically compute the mean of that difference and then compute the standard deviation. So remember back from way back in module 1 when we were looking for the mean and standard deviation, we go to Stat, Summary Stats, and Columns. We're looking for our DI column, that difference column, and we want our mean and standard deviation. So let's click Compute. What do we get there? We get negative, okay, round to 3 decimal places. So let's do this just so I can see it. Negative 2.575, check answer. That was right. And then the standard deviation we also have, that's 1.522 since we're rounding to 3 decimal places. There we go. Okay, test if the mean of the differences is less than 0 at the alpha equals 0.05 level of significance. What are the correct null and alternative hypotheses? So remember, our null hypothesis is always that difference is equal to 0. That's never going to change. So we could really eliminate all of them just by that alone. But then we can see here that our alternative is what we're testing for. See that? Okay. Let's find the p-value. So let's go back to StatCrunch. And we're going to go now. So again, we're dealing with matched pairs data and we're looking at the mean. So we're going to go to Stat, T-stats. Again, whenever we're dealing with the mean, we're going to T-stats. Now we have two sample. That's for the independent. So that's if they're independent means. This, we know that we have matched pairs data. So let's go to paired. Column 1 is XI. Column 2 is YI. So this one we are doing, we have a hypothesis test. Our null is that the difference is equal to 0. The alternative is that the difference is less than 0. So let's click compute. And there's our p-value of 0.001. You see that all right there under that p-value column right there. 0.001. Fantastic. Choose the correct conclusion below. So remember, if the p-value is less than alpha, then we reject the null hypothesis. Our alpha given right up here is 0.05. Our p-value is 0.001. Our p-value is definitely less than alpha. So we already know that we're rejecting the null hypothesis. So we know that our answer is going to be A or D. So let's go ahead and read the rest of it. This one says there is sufficient evidence that the mean difference is less than 0 at the alpha equals 0.05 level of significance. That is the correct answer. I just want to double check D just to show you guys the difference. This one says there is insufficient evidence. So remember, if we reject the null hypothesis, we're basically saying that we do not think that the difference is equal to 0. So we're saying that there is enough of a difference to support, or there's enough evidence to support the alternative. That means that there is sufficient evidence to support the alternative. Now, if we did not reject it, then we would say there's insufficient. But if we reject the null hypothesis, if we rejected the null hypothesis and then said there was insufficient evidence to support the alternative, that's saying there's basically no answer. So then if that just added confusion, let me know. I can explain that further, but I think that that's pretty clear. So we know that the answer is A. Good job. All right, compute a 95% confidence interval about the population mean difference. So let's go back to StatCrunch. We're going to go to Stat. Again, we're in T-stats, still in paired. We're going to go ahead and select our column XI, YI. Now we're going to go down. Instead of doing the hypothesis, we're going to check confidence interval. And we're doing the 95%. So we don't need to change the confidence level. We're going to click Compute. Get our lower and upper bound. So here our lower bound is right here, and we're rounding to 2 decimal places. That's going to give us negative 3.85, negative 3.85. And then our upper limit is negative 1.30, negative 1.30. Let me just double check those. Excellent. Now, I just want to point out something else here. One of the things that was kind of addressed in the book and in my lesson this week is you can use the confidence interval when you're dealing with a two-tailed hypothesis test. In this case, we are dealing with a the left-tailed hypothesis test. So in this case, it's not applicable. So I hope that answers any questions you guys have about number 6. If you have any other questions or have any more confusion about this problem, let me know.